meant to talk about that too, how it all started. So Marcelo and I were students at the Media Lab, which Julia mentioned, and started at the same time, finished my master's, did part of a PhD, and left, was doing something else. And Marcelo was in the PhD, and we won this award from Design Miami, which is part of Art Basel. It's a big art fair that happens twice a year, once in Basel, Switzerland, once in Miami. And it came with a commission to make a piece for Design Miami in Basel. And so we made this, and we had about 2 months from, here's your award, make something cool about, what did she say about the future of...
Yeah, we're asked to design something that we thought represented the future of computation, future of design. And to us was that, right? Computers becoming physical objects.
And so we spent every waking moment and thought making this for 2 months. And the way we made it, it's really amazing now that there's so many tools available for people to make things with. And if you tried to make this 10 years ago, it would be much harder. And 20 years ago, you would need a team of people to make it. But there's things like Arduino, which, if you don't know Arduino, it's a kind of very easy to use prototyping platform for electronics. And they have little boards that you can order online, and you can plug it in, and very easy programming environment, and you can program it, etc. And we both program microcontrollers in harder ways, but it's just such a nice tool that we use that. And we built our own PCB. But run some of the Arduino libraries on it. But there's a few different pathways, right? There's the electrical design, what the circuit's going to be and how that's going to be able to do what we want it to do. There's the software, the firmware, how we're going to program the behavior into the electronics. There's the physical design, what the case is going to be like, what materials it's made from, how it's put together, how it mechanically connects, mechanical engineering aspects of that, how temperature will change it over time, tolerances, there's glues in there to hold everything together, how you select all of that. There's also the user experience, the interaction design of how you interact with it, all of this after the concept of what it is that you want to make anyways, but then how you design all those things to fit together. And there's a suite of design tools out there that you can use to do all these things. You can design models in 3D CAD, and there's services like Protomold, which we use to do the injection molding, where you can submit a 3D CAD model and see how it would be molded. You can see how injection molding is this process where you have these big steel screws that heat up thermoplastic and melt it down and squish it into molds. And you can look at exactly where the gates will be, where the plastic will enter into the mold, what the thermal properties of the mold will be. If it's thin enough, you can analyze all this online so that we could, we've never done injection molding before, but we were able to really rapidly figure out how to do it by talking to their engineers. You could do a small, I think we printed 400 tops and bottoms the first time.
Yeah.
And for a fairly affordable price, like tooling costs for injection molding out of aluminum, which is what they do, is something like $2,000 minimum, and then depending on how complicated the mold gets, it can go up from there. But that's orders of magnitude cheaper than getting real industrial injection molding done with steel blocks.
There's also a lot of iteration in our design process. Like when we started, we're like, we think we want to make this thing that's going to do X and Y, and we then very quickly design a circuit board that would do those things and we test it out. Like in the beginning, like we'd make like little cardboard prototypes and put this stuff in and see how food will hold it. And it'd be like, well, maybe should we make it this size, maybe that size. And then you start advancing all the different fronts of your design at the same time, like the electronics, the case, the light quality, the glass, and they will sort of start to form each other. So originally you wanted to make something that was about this big, and then it was like, whoa, we can't really fit everything in there. This would be a bit bigger, and then the light quality was something that was really hard to get right at first. I wanted to make them really flat, but you get this really nice diffuse light. You need a lot of space between the LED and the diffusers, and then try to make them a little bit beefier. But then it's really nice because they had a really good grip. So there was a lot of kind of iteration and getting all these factors to influence each other.
Actually, there's a funny story. When we were really obsessed with getting the light to be a specific way. We wanted it to look totally flat. The light to have no point source. So you see the little round part in the middle? At first we were like, no, we can't have that. We can't have that. It's got to be flat. We tried all these different things to get it to be flat, and it was not working, and we were frustrated. And we were thinking about it, and we're like, okay, what can we do? And there's this thing called Oblique Strategies by Brian Eno and somebody else. I don't know if you've ever seen this. It's like a card deck with weird ideas on each card.
we're like, let's just see what this says, you know. So we picked up a card and it said, emphasize the flaws. And we're like, okay, well, what if we just make it a single point source? And then we're like, well, we start really liking that idea, and because it kind of gives it a little bit of that pixel core inside of it, you know. So it's like it's holding some type of energy rather than totally externalizing it, and various other conceptual language you could use. But so we settled on that. But it was really hard to get the lighting right.
You have a question, right?